So we're going to start talking about digital imaging, and there's basically just a few concepts in here that we want to talk about in order to understand what we're going to be looking at when we do some demos over the next couple of weeks. So let's go into slideshow mode. Okay. So when we're talking about digital imaging, we have two different types of images that we can use on a computer. And the big difference between them is the way that they think about data, the way that they think about the information that's contained in the image. And so we're going to talk about the advantages and disadvantages, what the kind of different stylistic concerns are, and a little bit about how the technology actually works. So a few of you guys said that you were into photography, right? And if you take a photograph and you print it, can you see, like, no matter how closely you look at the photograph, you'll never see these blocks, right? It's like infinite information, right? And that's kind of the main difference between, digital media and analog media. So whether it's film or photography or recording music on tape, analog media, has infinite resolution or infinite quality. There's no point at which we start to see the actual, blocks or jagged edges between the pieces of information, right? So that's a big difference when it comes to digital media and analog media. Most of the media we consume these days is digital, right? If we're looking at our phone, even if something was shot on a film camera, if you're watching it on your phone, you're watching a digital recreation of that film. You probably hear, people talking about how records are better than listening to Spotify, right? Or how watching a film is better than watching, something on your phone or something on your computer. And typically what they're talking about is the loss of data, the loss of quality that happens when we translate something from an analog form of media to a digital form of media. We've been in the digital media age for a long time, to the extent that it feels kind of pointless to even talk about it anymore. When I first started teaching, it was still more like relevant. People still had cameras, that they would carry around. This was before we had the iPhone, where everybody's phone is a better camera than what you would buy at the store. So those things have changed a lot. And so when we think about creating media for the internet and for digital media, our concerns are a little bit different. And what we want to think about is the relationship between the technology and the quality of the image that we get. And so that's a lot of what we'll be talking about, is how to get a better quality image, get a better quality media using the technology that we have available. So we can see this picture here. This just looks normal, right? You don't necessarily know what the data of this is. We don't see like blocks and stuff like that. But when we zoom in, we start to see how the computer thinks of this image, right? The computer doesn't see sushi and stuff. The computer only sees blocks of color and what those color values are, so that we can recreate the image in a way that looks, to a person like what that image looks like. So for example, this pixel here, the color value can be expressed as three numbers: the amount of red, the amount of green, and the amount of blue that combines to make that image. And so this comes from how the computer works. Most of our computers, the screen is just a huge array or matrix of pixels. And when we want to display something on the computer, we have to tell it how much light to put into each one of those pixels. And so when we create an image, we have to say, take pixel number 0 or number 1 and put a little bit of red, a little bit of green, a little bit of blue. And then we have to do that for like 1 million pixels or however many pixels there are on the screen. So that's one way of thinking about image. Digital images, that's one way that digital images work. And the computer uses the RGB Color Model. So this stands for red, green, blue. You may have heard this before. And you can see we basically have 3 different colors that we combine in different amounts to get an incredibly large number of possible colors. And that's how pretty much every color on every computer is generated, by saying how much of these 3 values that we want. So for example, so red over here, the R value is 255. Typically, if you're working with a computer, your range for a value is going to be between 0 and 255. That might seem kind of arbitrary, but that's how much information 1 byte of computer data can store. So it's done that way to optimize how fast the computer works. So if we want a color that's completely red, we're going to have 255 as our red value. That's how much red light we want that pixel to produce. If we want it to be green, we're going to have more of our G, our green value, than our red or our blue. And then obviously for the blue, this is with 0 red light, 0 green light, and full blue light.
So the highest value just moves over?
Yeah. So the 3 values represent red, green, and blue. So this one is you have all of the possible red and 0 of the possible green, 0 of the possible blue.
Oh, okay. So I'm going to say the highest value.
Yeah. So that's how we get red. So then with these colors like this black here, there's 0, 0, 0. There's no red, there's no green, there's no blue. So we end up with black. With this one, we have 255, 255, 255. So the most red, the most green, the most blue. When we put them all together, we get white. So they blend together. This one is kind of hard to see on the projector. There's kind of low values. But it's easy to see this. It's like kind of a dark green. I don't know if that's the best example. But if you go to color.adobe.com, we'll use this a lot. You can see this working. There's a million websites that will show you this, but you can see RGB, and if I move this color around, you can see those values moving around. So actually, let's select A. So if I have R over here, you can see the R value is really high. The green value is kind of in the middle, and the blue value is all the way down here. But if I take the blue value all the way up, then I get something like pink. If I take the green value all the way up, now I have that white. If the colors are all balanced, then it's going to be monochrome. It's going to be gray. And if there's no color at all, that's when we get black. So we'll use this more during the semester. Okay. So this is some like nerdy computer stuff, but one of the terms that you'll hear when you're talking about digital media is bit depth. And bit depth just refers to how much data is in the image or audio or whatever media it is. So 1 bit, so the way that computers work essentially is like really like tons and tons of switches. And switches are either on or off. Its electricity is either going through the switch or it's not. Like when you switch a light on and off. And it sounds kind of crazy. But, you know, if you were, let's say you were going to do Morse code, right? Like you were trying to communicate with somebody over there, and you could all you could do is turn the light on and off, but they could see it. If you both know Morse code, you could actually communicate, right? Like you could say, you know, a sentence or whatever. Do you guys know what Morse code is? Is that, yeah. Okay. So you could actually communicate from here to there as long as they can see it and as long as they understand the same language, right? Computers basically the same way, but going like a million times faster. So all electricity is either just on or off, but if we put together enough of that and do it fast enough, we can do really complicated stuff like draw an image of sushi on the screen. So on some level, everything that's happening is either on or off. It's either 0 or 1. That's 1 bit. Okay, so when you're putting data together, if the whole image is just black and white, you can express it really easily. You can just say 0 for black and 1 for white. Or you could reverse it, 1 for black and 0 for white. If you need more than that, then you need more information. So if you have 2 bits, you have 4 possible values, so you have a little bit more information to work with. When you get up to 8 bits, you have 256 possible values. So if you have 8 bits, if you have 8 0 or 1s, using binary, you can express values from 0 to 255 is how it's normally expressed, or 1 to 256. So you have 256 different values. So we have 8 bits for red, we have 8 bits for blue, and we have 8 bits for green. Sometimes we also have 8 bits for alpha, or transparency. So that's how we express data on the computer with media. And if you hear somebody talk about bit depth, they're talking about how much information is in a particular piece of media. So we don't really think about it so much as we used to because computers are super fast and have lots and lots of data storage. But when I first started working with computers, like in the 90s, you were really like trying to make things as small as possible because otherwise they were really, really slow. So if you wanted to make a game or a website that worked, you really had to care a lot about the amount of information that was going in between the computer. Okay, so sampling and quantization. This is another thing that you'll hear about when you're talking about digital versus analog media. This essentially means like, if this is the analog, okay, if you're recording sound, this is sound, but it could represent any type of information. If you're recording the analog, you have like that infinite resolution we talked about, right? Like no matter how far you zoom in, it's still going to be a clean line. When you have digital, eventually you're going to run into these blocks. Eventually when you zoom in, eventually you're going to have these blocks. You're going to see the different parts of the information. And what sampling refers to is how often do those blocks occur. So with this piece of audio, we're basically sampling what does it sound like here, 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 here. And then when we play that back, it doesn't sound exactly the same, but if it sounds close enough, then you can make a file and you can put it on Spotify and people won't know the difference, right? Especially if you're listening through your phone speaker or whatever. So the more samples you do, so if I put one here and here, or if I put 10 more here, then the more it'll sound like the original audio that you're recording. But it'll also take up more information on the computer. So I'm recording this lecture right now, and at a certain point, if I just recorded forever, the computer would just break, right? It would say, I can't keep saving all this data. Hopefully it would turn off the recording, but I think it would actually, I don't know, it might just break. So when I set up the recording, I didn't actually look at the settings, but I could change the settings to say, I don't need this recording to sound perfect. I just need it to sound good enough that when I play it back, I'll be able to understand it, right? So there's this trade-off between the amount of information and the quality of the information. That clock is not right at all. Okay. Okay. So image size, we'll look at this when we use Photoshop, but this is essentially just like how many pixels are in an image. It's actually, there's a lot of different variety now, because it used to be that there was basically like, a few basic standards that you had to worry about, but now there's like a million different phones that are all different sizes, and if you want your images to look good, you have to like test them on all different sizes. But we'll take a look when we use Photoshop on Thursday at what this means. But essentially, it's the number of pixels that we have in an image. So the example here is our icons are 120 pixels by 120 pixels. That's kind of the standard. It's probably bigger than that at this point. Honestly, it gets bigger. Every new phone obviously has more pixels in them. So the image resolution is the number of pixels that are within the screen. So you have like the physical dimensions of the screen, like your iPhone might be like 3 inches wide and 5 inches tall or something like that. But the image resolution is how many pixels go into that space, because we can fit more and more pixels in there. So you guys have probably heard of like high density screens, which are actually honestly pretty old at this point, but they figured out how to put like basically 2.5 times more pixels into the same amount of space. And now it's like everything looks super, super clear and clean, right? And if we look at something from the past, it looks kind of messed up, right? We can start to see the blocks. We can start to see where one block turns into another block. Especially if you ever watch like old movies or old sports highlights or something like that, you'll see like something that looked normal 10 years ago looks really crappy today because this stuff changes so quickly. So we'll look at examples of that on Thursday as well. Yeah, so then that's obviously related to the display resolution. So you can see the first iPhone from 2007 over here. This is how many pixels were in it. And here we have 2016. And then, if you fast forward 5 years from there, that number probably gets a lot bigger as well. So the first part that we'll be looking at is what we see on the right is raster images. So this is the style that Photoshop uses mostly, and this is the style that we're talking about where each block or pixel is a different color. And we'll start with that, but we'll also look at vector images. So computer graphics typically use one or the other of these two different styles or approaches. A raster image is literally, it's just like, what is every pixel and what is the color? A vector image uses points and it uses colors and it fills in the space in those points with whatever color. So a raster image, depending on what type of imagery you're doing, it can be more efficient and it can also look a lot cleaner. But if you have a ton of data, you need to use a raster. So if you have something that's just one big color and if you want a really clean, nice shape, you're going to use a vector image. If you need a lot of detail, like you want some like grass or something like that, then you're going to need a raster image. And we'll look at how to use them and what the differences are. Most of the images of like that you take on your phone, those are all raster images. Icons and stuff like that, those are vector images because you want those clean lines. It's easier to see. So we'll look at different contexts for those two different types of graphics. And we'll go into vector images more. We're going to start with Photoshop and then move to Illustrator. So we'll look at vector images a little bit more when we actually use Illustrator. Raster images is what we're going to start with, and we'll look at the different file formats for raster images. So we'll start with Photoshop, and we'll create just Photoshop files, and then we'll look at, we can output all these different types of files, and they all look a little bit different because the technology that decides where the different pixels go is a little bit different. And there's different reasons for that. So a lot of it has to do with the web. So JPEGs, you guys have heard of JPEGs, right? So a JPEG is called a lossy image, and that has to do with what I was talking about with the sampling before. So when we say lossy, what we're talking about is the information that gets lost. So if we're just sampling this color and this color, we lost all of that information. And so as I said before, if it's close enough that people don't notice, then it doesn't really matter, right? But there's this trade-off between size and fidelity, or how good the image looks. And so we want to have something that's not big, because it'll go faster if we text it to somebody, but we still want it to look good. So all these different images have different ways of dealing with that problem. So JPEG tends to make the colors more blocky. PNG is lossless, so it keeps all of the information, but it's bigger, the files are bigger. So it looks better, but the files are going to be larger. So if you're making a photography website and it's like the photo has to be perfect and it has to look great on every computer, you'll probably use a PNG. GIF is really crappy format, but it is animated, which is why we all still have it. But all of your GIFs are actually videos in disguise, and we'll maybe go over how that works. TIFF files, people don't really use these anymore, but it used to be the standard for like the highest quality files with the most information. So this is kind of a example of vector graphics versus raster. So raster is typically a photo. It has a ton of detail. Like there's all these little dots on the street and stuff like that. If we tried to actually describe the shapes of all those things, it would be like a ton of information. But since all we have to describe is the colors, we can do that. With a vector graphic, all we have to describe is like this point, this point, this point, this point, that's brown. And then this point and this point and this point and this point is darker brown. And so you can see the quality of a vector graphic is more flat. There's not all the detail, but it's clean. It looks nice, and it looks more digital, right? Okay, we'll go over all this stuff when we're actually doing stuff. This as well. And copyright. So this is the last thing we have to talk about. Oh, we have plenty of time, actually. Okay. So on Thursday, we're going to start making some image collages. So we're going to look for images on the internet. We're going to put them into Photoshop, and then we're going to, make them smaller, make them bigger, move them around, change the colors, do all sorts of fun stuff. One of the things that we are going to be aware of and that we're going to be talking about as we take different types of media is licensing and copyright. So You guys are probably like vaguely familiar with like licensing and copyright, right? If somebody makes something and they copyright it, other people can't use it except for in specific circumstances. Creative Commons is a type of license where the original creator specifically says like, I want other people to use this. Like I made this so that other people could use it. And they may create certain rules for that. They may say like, you can use this, but you have to put my name on it, or you can use this, but you can't change it, or you can use this, but you can't make money off of it. There's different rules. One of the things that we'll look at is using Creative Commons media to create our own work. Usually it's free, which is a big part of why we're going to do that. You know, if you're running a news website and you want to run an article about like Michael Jordan or LeBron James or something like that, and you need an image, you're going to pay money for that image, right? It's not going to be free. We don't want to pay for stuff, but we also, I personally think the Creative Commons movement is cool. It allows people to share information and share media and create new projects. So that's what we'll be focusing on. There's a search engine specifically for Creative Commons media. There's other places that you can use to get Creative Commons stuff, like Wikipedia has a lot of Creative Commons stuff, or Wikimedia rather. There's Google search, you can say I only want Creative Commons stuff. So there's a few different ways to do it. But there's also the Creative Commons search. So we'll look at this on Thursday. And then when you do need to do a citation, this is how you do it. So you're going to have the name of the work, the author's name, and then the license, and typically a link to where you got it from. So that's just a good thing to get in the habit of if you're creating media. You know, if you make a podcast and you have some background music that your friend created or you just found on the internet, whether or not you paid for it, you want to give attribution to the person who created it. So, you can support the person who created it, and also they won't sue you. So yeah, that's everything we got to talk about. The file naming and the practice stuff, we'll do that when we're actually doing files and practice. So we'll do that on Thursday. And so yeah, just wanted to like cover a bunch of terms that we're going to be using. On Thursday, what we'll do is we'll actually do a demo in Photoshop. So we'll open up Photoshop and we'll take a look and just add some images and start playing around with them, see what the different tools are and stuff like that. And then we'll have some workshop time for you guys to work on your project. So should be about half and half, but we'll see how long it takes.